What is up, YouTube, and welcome to another episode of Kubernetes in the cloud. So today's cloud is going to be Amazon Web Services. If Amazon AWS is not your cloud provider, feel free to follow along anyway. It'll improve your skills as an engineer to understand the fundamentals of multiple cloud providers. In this video, we're going back to basics. That means no cloud provisioning tools, no automation tools, no complexities. We're going to focus on the basics because the fundamental basics is key. We're going to use the command line to see what it takes to provision a Kubernetes cluster on Amazon Web Services. So without further ado, let's go. Alright, so let's break it down into steps. What we are going to do, we're going to create an Amazon AWS free account. This will give us access to the free tier, and I'll talk about that in a second. What we're going to do then is we're going to install the AWS CLI. This is the command line interface to interact with Amazon Web Services. Then we're going to use the CLI to log in to our free account and create what's called an IAM role. This is kind of like a service account that manages our Kubernetes resources. We will then also use policies. Policies in AWS are managed by AWS, and they basically give our IAM role the ability to do things with our Kubernetes cluster. There are a couple of policies that we'll need to assign to this account. Then what we will do is we will use this account and the AWS CLI to provision what's called a VPC. For those of you who don't know Amazon, VPC is like a virtual network. So what we'll do is we'll spin up a VPC and we'll divide it into 3 subnets with different IP ranges. This will give you an idea of how to install Kubernetes into an existing virtual network. Then what we will do is we will create what's called EKS. This is the Kubernetes service for Amazon. Now this service is not free. It'll be charged roughly $0.1 per hour to run. Then the final thing we're going to do is use the free tier to create an EC2 instance or a virtual machine in one of the subnets. So we'll deploy a virtual machine here from the free tier and connect it to EKS. That is using the Amazon AWS CLI. Another option we'll take a look at is using EKS CLI to basically do the same thing, just in a much easier, simpler fashion. Now for Amazon EKS, basically what EKS is only the control plane of our Kubernetes cluster, so the master node. When we spin up an Amazon EKS, we pay 10 cents per hour for each of the clusters we create. So in this demo, what we're going to want to do is create a free Amazon account. So you come over to Amazon's website, look for the AWS free tier, and what this allows us to do is this gives us access to compute virtual machines like small ones, so T2 micro and T3 micros. This will allow us to spin up virtual machines that we can connect to our EKS cluster as worker nodes. So what you want to do is come over here, click on free account, and then you fill out the information. Now what all cloud providers do is they ask you for your identity and credit card information. They do this to prevent fraud and also make sure you are who you say you are, preventing bot accounts, spam accounts from misusing the cloud infrastructure. So for those of you who are new to this channel, everything I do is on GitHub in the Docker Development YouTube series. You want to look for the folder Kubernetes and Amazon, and inside here I have a getting started page. So all the commands and everything I do is recorded here so you can follow along. So the first thing we need to do is look at the Amazon's command line interface. So for that, the easiest way to do this is to install Docker and head over to Docker Hub, look for Amazon AWS CLI, and this is the command line interface for Amazon. So what we're going to do is we're going to say Docker run, we're going to run an interactive container, and we're going to mount our source code into the container so we can do all the work inside of this Docker container. We're going to create a bash entry point, and we're going to run this version of the Amazon CLI. And then I'm going to change directory into this Kubernetes Amazon folder, and if I do ls, you can see we're now inside of the container, and we can see our getting started guide over here. And then what I'm going to do is I'm just going to use yum, and I'm going to install JQ. JQ is basically just a utility for managing JSON files, and since Amazon CLI works a lot with JSON and all the security policies are in JSON, we're going to use JQ to process them and work with them. So now we're ready to log into AWS. So now that we've installed the CLI, now we want to configure our AWS CLI credentials so we can start talking to Amazon. So the way to do that is sign into the console. Once you're in the console, you want to click on your user account and click on My Security Credentials. So what you want to do is come over to Access Keys and click Create New Access Key. This will generate a new key which you want to keep secure. So you want to keep the access key as well as the ID. Now, usually when you deploy a Kubernetes cluster to the cloud, every cloud provider has different data center regions to deploy to. So you're going to want to go over to Amazon's documentation on regions and look for the region that is suitable for you to deploy your cluster to. So for me, I'm going to just deploy to Sydney. So you want to get the region code for the cluster that you want to deploy to. So go ahead and grab that. And then what you want to do is log in to AWS using the CLI. So you say AWS configure, pass in your access ID, your secret key that we got from the previous step. The region name is the default, and then output is just going to be JSON. So one thing I like about command line interfaces is that they should be self-documented. So if you go AWS, these are the commands we can run. So AWS has a bunch of sub commands, and we can use the help command to get some extra text. Because we're going to be using the AWS CLI, so what we want to do is say AWS help, and this gives us the help documentation. So if we scroll down, you can see there's quite a lot here, and if we go all the way down, we can see the list of services that we can interact with. So the CLI allows us to interact with compute. We can have a look here. There's like Athena, there's auto scaling, there's app config, the list goes on. All the different, there's cloud formation, cloud search, cloud build, cloud watch, code pipeline, and the list goes on. We want to go down to E for EKS. You can see we have EKS as a sub command. That's the one we're interested in. So just press Q to quit, and we can say AWS EKS help. And let's have a look and see what we can do with this tool. So we can create cluster, we can create node groups, we can delete clusters, we can describe them, we can list clusters. So a bunch of stuff we can do with our EKS cluster once we've provisioned it. We want to go ahead and create an EKS cluster IAM role. So roles and service accounts in Amazon is used to do things and interact with the cloud. So we need an IAM role and basically use the role to assign policies to, so that we can use that role for EKS to manage our cloud resources. So when EKS needs to spin up a load balancer or it needs to scale out EC2 instances, it'll use that role to do so. Now I've added all the steps here to do so. So what we're going to want to do is we want to run the AWS IAM create role command. We give our role a name, so I'm just going to call it getting started EKS role. Whenever you create a role, you need to assume a policy. So we're going to create one role for our EKS cluster, and then we're going to go ahead and use this JSON file as a basic policy. So we basically say allow assume role for the service eks.amazonaws.com. So we pass in that policy document over here, and then we read the ARN number back from that JSON that comes back. So we want to go ahead and run that. Now, if we take a look at this environment variable, this identifier. So ARNs are basically identifiers. So we've created a role, we got its identifier, and now what we're going to want to go ahead and do is create policy. So for our role to be able to do anything, it needs a policy attached to it. Now, AWS has a couple of managed policies for EKS, so we don't have to worry about the granular details. So if we take a look at the next command, we're going to say AWS IAM attach role policy, and we're going to attach a policy to our existing role, and the policy is going to be a managed policy. So there's an Amazon EKS cluster policy that Amazon provides us, and now our role is ready to go. So the next part of this guide is we want to go ahead and create an EKS cluster VPC. A VPC in Amazon is basically a virtual network. So you can either use an existing virtual network, or in this demo, we're just going to create a new one from the sample guides here. So take a look, have a read through this guide, and you'll see what they do is we going to grab a template, and they have a bunch of different templates. You can create public and private subnets or just public subnets, and they basically talk you through what all the fields in the template means, and then you can either go and create it manually, or you can use the commands that I've already created here. So I basically just say curl and I'm going to pull down this template here of a sample VPC. This is just going to be 3 public subnets that we want to use. So I'm going to go ahead and download that. Now, if I do ls, you can see we got the vpc.yaml here. Now, feel free to have a look at this YAML file. If you know a lot more about AWS, you can play around with this, but you can have full control over the subnet and the VPC that you want to deploy. So things like the subnet IP address ranges, whether you want more public subnets or more private subnets, it really doesn't matter. You can go ahead and tweak this file, or you can use an existing VPC or even a different template or Terraform or whatever you want to do to create a VPC. So we're going to go ahead and run this next command, which is AWS CloudFormation deploy, and we pass in our template file of VPC and we call our stack name getting started EKS. Go ahead and deploy that, and that'll take a couple of minutes to deploy. Now, while that's running, go ahead into the console, click on service and click on CloudFormation, and you will see your getting started EKS stack running. And this is basically just spinning up our VPC with public subnets. And now that our virtual network is up, if I hop over to the GUI and I refresh this page, we can see that it's done. So it's completed, created our VPCs, ready to go. So now we can go ahead and deploy a Kubernetes cluster in that VPC. So what we want to do is we want to say AWS CloudFormation. We want to list the stack resources because there's going to be VPC subnet IDs that we might want to use to drop a Kubernetes cluster in that VPC. So you want to run that. And then I'm piping that to stack.json so that we can go ahead and look at the stack resources. So let's take a look at this list. So we have control plane security group, we've got internet gateways, we've got routes, route tables, subnet. So here we go, subnet. And what you're going to need is like the subnet IDs that you want to drop your Kubernetes nodes into. So we see we have subnet ID 1, we have subnet 2, and we have subnet 3. So if you're using an existing VPC, you're going to need the subnet IDs in order to proceed. So you can drop a Kubernetes cluster in that existing VPC. Now, before we go ahead with the create cluster command, let's just take a look at the resources VPC config. Now, when you create a cluster, you say AWS EKS create cluster. You give it a name, and then you also provide the role identity. So that role identifier that we created earlier, we want to provide that. That'll tie up the EKS cluster with that IAM role. And this is the important part, the resources VPC config. So in the stack.json file, you'll have all the resource IDs of the subnets that I showed earlier, as well as security groups. So you need to provide that into this command. So if we take a look at our create cluster command, you can see subnet IDs. There's a list of the subnet IDs that we want to have Kubernetes have the ability to spin up nodes in, and then also the security groups, and also whether we want public or private endpoint access. So what I'm going to do is I'm going to go to my stack.json, I'm going to find my subnet IDs, and I'm going to add them here into this comma delimited list. And then we're going to scroll over to the right, we see security groups as well. So we're going to go ahead and find our security groups. Here is the security group, control plane security group. So we're going to grab that ID as well, and we're going to say whether we want endpoint public access. I want that true, otherwise I won't be able to access my Kubernetes cluster. So then what we want to do is grab this command and we're going to paste it into the terminal. So this will spit out a bunch of JSON that we can see here. We can just press Q, and that means our cluster is now busy creating. Then there's a few things we can do while we wait for that cluster to be created. We can say AWS EKS list clusters. You can see our cluster is listed here. If we want to get more details about the cluster, we can say describe cluster and pass the name in. This will give us the JSON output. And if we take a look down here, we can see it's in a status of creating. You can also come back to the portal and just type in Kubernetes, and you'll see Elastic Kubernetes services. If you click into that, we'll be able to see, here we go, our cluster is here and it's in a creating state. So now that our cluster is up and active, we can go ahead and access our cluster. So to do that, we need a kubeconfig. So we're going to run a command, AWS EKS update config. We pass in the name of the cluster as well as the region. So if we go ahead and press enter, this will go ahead and download the kubeconfig and put it into our root kubeconfig folder. We can then run the copy command to bring the config to our local folder, so we can have a look at that. This is the kubeconfig to access the cluster. And next bit here is I'm just going to go ahead and install kubectl, since we don't have kubectl in this cluster, install kubectl and move it to user bin, and now we're good to go. So the first thing I can do is say kubectl get nodes, and when we run that, we can see there are no nodes attached to the cluster. This is because we've deployed an EKS cluster, it's just the control plane, and now we have no nodes attached to that cluster. So the next thing we need to do is create another role, and that role is going to be managing what's called node groups. And what we can then do is we can use some of the free tier machines to attach to a node group and deploy them into the VPC of our Kubernetes cluster. So let's go ahead and do that. So what we want to do is create another role. So what I'm doing is I'm saying AWS IAM create role, and I'm creating a role. This time I'm calling the role with the same name, but I'm just attaching nodes to it. So this gives you granular permission control for each node group running in your EKS cluster. So we're going to create a role with that name, and we're going to assume this time node policy. So I got this off the Amazon website, and pretty much all this is another assume role permission for ec2.amazon.aws. Because we're going to be spinning up EC2 instances, we're using that as our assume role policy document. So we pass that in, and then again I'm going to grab the resource identifier number out of that. And what I'm going to do then, just to show you, and we have our identifier for that role ready to go. So these are the three managed policies that we need to add. So the Amazon EKS worker node policy is more about worker node security. And then we have one for CNI policy. This will allow container networking on that node group. And then we have one for EC2 container registry read only. So if you have a container registry on your Amazon account, you can actually hook that up so that node can pull from that registry automatically. So what we're going to do is we're going to go ahead and attach these three policies by just pasting the commands into the terminal. And now our node pool role is ready to go. Now, before you create your cluster, it's important to have a look at the instance types that Amazon provides. So if we take a look at the documentation, they provide a bunch of different machines: general purpose, compute, memory optimized, basically all storage. All cloud providers have different types of machines. So you're going to want to pick some of the machines. Now you can either use free tier machines, or you can go ahead and pick for whatever types of workloads you're planning to run. So I'm just going to go ahead and go with the T2 small instance. And then if we take a look at my command, I've basically just got the bare minimum, more sensible type command here that you want to look at. It's AWS EKS create node group. So we're going to give our cluster name. We're going to give the node group name. So give it a name that is meaningful to you, or you can just call it default. And then what you want to do is pass in that node role. So this is the identifier for that role we just created for our node group. And then we also have the subnet ID we want to put the node group in. So if we go back to stacks.json, I'm just going to take, in this example, I'm just going to use my first subnet. So I'm going to grab that subnet ID and I'm going to paste that in here. Then the other thing is you also want to make sure you get enough disk space. When you're running containers and there's a Docker host on that machine, it's going to sometimes run full of Docker images unless you go ahead and manually clean it up. And I find a lot of cloud providers put a very small disk on their machines, and not all cloud providers do this, but I always suggest to explicitly say how much storage you need, and then we can say how much basically the scaling config, so how many instances we're planning on running. So for this demo, you have like a minimum size and the maximum size, and then desired. So I'm just going to go with a desired of 1 because I'm not really going to scale for this demo. And here we're just going to pick our instance type. So I'm going to go ahead and grab this and I'm going to paste it in the terminal and hit enter. And if we go back to our Kubernetes cluster and we click on the cluster here, we can see if we click on compute, we now have a node group that's busy creating. So feel free to have a click around here and a play around with the logging, updates, networking. It's a pretty in-depth dashboard, pretty cool. You can also add Fargate as a profile, so you can use Fargates instead of EC2 instances. So now we can see our node group is finally active. We say kubectl get nodes. This time we can see now we have a node attached to our cluster. So what I'm going to do as part of this demo, you can see I've got to create some sample resources just to show you how to interact with the cluster. I'm going to go one folder up, and then if we say ls, we can see we have a Kubernetes folder. We're inside the Kubernetes folder. So let's create a sample namespace. I'm going to create a namespace called example app. and then I'm going to deploy a secret, a config map, and a hello world app. I'm going to go ahead and run those commands, and then the last thing I'm going to do is apply a service type load balancer. And while that's applying, let's take a look at the service load balancer. You can see here type is load balancer. So what this does is it tells Kubernetes that we need a load balancer exposed for this hello world app. So if we take a look in the Amazon portal, we should see an elastic load balancer being provisioned, and I can confirm this by saying kubectl get service in the example app namespace, and we can see we have an examples app service here running with an external IP. So Amazon has gone and created a load balancer in the cloud, and we can then take this IP and I can open up a browser window, and we can see if I go to the browser with that address, we can see our hello world app is now up and running. We can also go into the Amazon portal and go to the EC2 dashboard and look for load balancers. We can see this load balancer has been created here automatically by Kubernetes. Now, if you're interested in knowing more about Kubernetes, check out the links below to my Kubernetes development guide. I basically cover namespaces, I cover deploying Kubernetes on local Mac and Windows, how to configure kubectl to interface with a cluster. I cover deployments, config maps, secrets, services, and ingress. So more little in-depth tutorials on Kubernetes I have available in the links down below. Now let's take a look at the other alternative. So creating an Amazon EKS cluster with EKSctl. So for that, I'm going to take a look at installing the EKSctl, and because I'm running in a container, I'm going to grab this here. Now because I'm running inside of the AWS CLI container, I have to install tar, so to unzip the package. So I say yum install tar. That's going to go ahead and install tar, and then I'm going to just run this command, which is going to go ahead curl. It's going to download EKSctl and extract it. Okay, and then what I'm going to do is I'm just going to extract that zip file into EKSctl. I'm going to chmod, and I'm going to move it into user local bin. So then I can say EKSctl, and we're good to go. So we can say EKSctl create, get, update, upgrade. So all the different commands we can run against Kubernetes. So this is a little bit more Kubernetes focused tool. So it's kind of similar to the other cloud providers like AKS and GKE, where they have really specific commands to the cluster. This, I think AWS has just gone with a separate utility. So you can either use AWS CLI, which is for the larger ecosystem, or we can just use EKSctl. So if we dig a little bit deeper, we can say EKSctl create help, and we can see there's a bunch of things we can create. So very similar to the AWS CLI, we can create a cluster, we can create a node group, we can create an IAM service account, we can create the identity mapping, and we can create a Fargate profile. So we can hook up Fargate to it or node group EC2 instances. And then if I say EKSctl create cluster, we can say -- help. And this gives us all the different information. Now again, very similar to the AWS CLI, we can provide names, we can provide zones and regions, we can provide a config file, we can do VPC stuff here as well. So we can actually add an initial node group that we want, so we don't have to specify a node group command separately. We can do it as part of the creation, so attach our EC2 instances. We can get SSH public access keys for that as well. What can we do? Here's all the VPC networks. So if you have a VPC that already exists, you can go ahead and attach your nodes to that VPC automatically here. Then we also have a bunch of kubeconfig file stuff we can do. So I've come up with a very similar command, but this time for EKSctl. So you can see the two side by side here. And this one I'm going to say EKSctl create cluster. I'm going to pass in the name of the cluster. This time I'm just going to say -1, and then I'm going to go into the same region. I can specify the version of Kubernetes. Here we say we want a managed node group. We're going to specify we want T2 small instances, and we just want one node and the node's disk size. So I go ahead and paste that into the terminal, and we can see that Amazon has gone on its way. It's going to create a new VPC as part of this, attach those machines into those subnets, and there we go. So we can see we now have two clusters. One is done with EKSctl and the other one with AWS CLI. And if I go into this one, they're both now active. You can see all the API server details here. Now you can see if we go over to the compute section, we don't have any node groups yet. One thing I did notice, if you go over to the cloud formation, portal, you can see that basically EKSctl just wraps around CloudFormation. So it uses CloudFormation here to spin up the VPC and all the underlying infrastructure, and now it's in progress. It's creating a node group, so it's creating our compute once our cluster is now up and running. And there we go. So if you refresh that, you can see our node group has appeared, and we have one small machine that's busy creating here as part of the node group. So it's very important to understand the differences between EKSctl and AWS CLI. That's why I'd like to highlight them both as part of this demo. So if you followed along, also remember to go ahead and clean up all the resources. So I've left the script here. I'll just run through it quickly. We're going to use EKSctl to delete our cluster. Then we're going to use AWS CLI to do the rest of the cluster deletion that we did. So we want to firstly delete the node group, then delete the cluster. Then we want to detach the policies to the 2 roles we created, and also the 3 policies we have on the node role, and then go ahead and delete the node role as well once we're done, and then also take down the VPC stack that we created for AWS CLI. So this will make sure that we don't incur any costs. So that was our very basic guide of Amazon EKS on how to get a cluster up and running and how to customize a cluster for your existing infrastructure network. Now, if AWS is not your cluster, please stay tuned. I do have a video on Microsoft Azure, Google Cloud, as well as DigitalOcean. If I haven't covered your cloud, please let me know down in the comments. Now, I know we only deployed a Hello World application in this demo, but that's because we're mainly focused on getting the cluster up and running in the cloud. In a future video, I will go through the whole CI/CD process of different CI/CD pipelines and technologies that you can leverage to deploy your applications to a cloud-based Kubernetes cluster. So I hope you guys enjoyed it. Hope you found it useful. Let me know down in the comments what sort of stuff you'd like to see in the future. And until next time, peace.